Okay, hi again, and we are going to look at a lesson that is needed for your 114 class today. And what we're going to look at is the last two forms that we are using to figure out the size of the sample set. And so it really helps us with our probability. And so these two forms are going to be permutations and combinations. And we'll go more into details about these two forms in a bit. But first of all, one of the skills we need to be able to do permutations and combinations is a skill that uses something called factorial. Factorial is designated by this symbol. N stands for the number, and then we put an exclamation point on it. So n factorial. So what this means is if we had a number like 6 factorial, this means 6 times 5 times 4 times 3 times 2 times 1. That is what factorial means, is you start with the number that you're at and decreasing all the way to 1. And factorial can be done on a calculator, but for now I would like you guys to do them without the calculator, and I'll show you why in a bit. So 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. And you have actually kind of seen this already. If you had 5 people that you wanted to arrange into 5 positions, different positions in a company. For the first position, you would have a choice of 5 people. But once a person has a position, that person is no longer in the group. So the second position only has 4 people available. The third position only has 3 people. The fourth position has 2 people, and the last position has the one that's left. So the number of ways you could arrange those 5 people into this company, into these 5 positions, is 5 factorial. So you've actually seen it, you just didn't use it. So that's kind of interesting that you've already actually done it just a little bit. It's just not something you used. So now if we were to multiply this, I would start here and get 30. This is 12 times 2 is 24. So 30 times 24 would be 0, 12, carry my 1, 3, 6, 7. 720, because that times 1 is still 720. So you can calculate it by your multiplications. And so factorials are what we're going to use with permutations and combinations. Now, in the assignment with these factorials, you're actually going to use them in more ways than this. You will see an assignment that will say something like 8 factorial divided by 6 factorial. So how do we do that? Well, yes, it could be done in a calculator, but I want to see the work. So here's what's going to happen. 8 factorial, you're going to say 8 times 7 times 6 factorial. Why? Because I have 6 factorial in my denominator. So 6 factorial goes in the denominator. 6 factorial cancels with 6 factorial, leaving the number 1 in your denominator. And 8 times 7 is 56. Not so hard when we can do it that way. So let's look at some others that you might do. Maybe you'll have 12 factorial times 5 factorial over 8 factorial times 4 factorial. Okay, again, you would do the same thing. I would start with my 12 and only go down to 8 factorial. So this would be 12 times 11 times 10 times 9 times 8 factorial. And there's that 8 factorial in the denominator. They're already canceled. Times 5 times 4 factorial, and there's the 4 factorial in the denominator, and that one cancels with that, leaving 1 in both cases. So I am left with 12 times 11 times 10 times 9 times 5 over 1. Okay, so let's see. Can I do that in my head? Let's see, 132 times 45 times 10 makes 450. I can't do that anymore in my head. So I would finish that up with a calculator because of the size of the numbers. But you can see how this works. It's really kind of cool the way you can manipulate factorials. So now let's look at the next step of it. The next step of it is to look at combinations. Now, no, let's do permutations first. Permutations are where the order matters. In other words, we're going to build a sample set where the order matters. What does this mean? This means that we have different groups the minute we change the order of what's in the sample set. If I have a sample set of A, B, C, D, E, and I want to know how many groups of 3 in a group I can make, and they're going to be like positions or something like that. So the order matters. So what's going to happen here? Well, to have 3 in a group, I could have A, B, C. That's one way to do it. This is 3 different people for 3 different positions. But guess what? BAC also counts as a group. Why? Because they're in different positions. And CAB is another group that is different, even though they're the same 3 letters, because the positions are different, they're considered different groups. This is what it means when it says order matters. Instead of one group meeting these, this is 3 different groups, 3 different outputs, okay? So it's important to understand what that means. Whereas combinations, on the other hand, the order does not matter. So what does that mean? That means with combinations, for example, ABC and BAC and CAB, which up here are 3 different groups, this is all one group. In other words, in combinations, it's like you're selecting a committee of people. And when you're selecting a committee of people, there's no positions, there's no first, second, and third place. Therefore, the order does not matter because it's just a group of people that have been selected out. So those are some of the words you're going to be looking for to tell you which one you're going to choose. If it's permutations, you're going to be looking for words like positions in a line, first, second, and third place, something that each thing differs. Okay? Whereas combinations, you're going to be looking for words like select a group, select a committee, something like that, where the grouping, the order in the grouping has no significance at all. So you can see that combinations, if we use combinations, we are going to have a smaller sample set than we will with permutations. With permutations, you'll have a much larger sample set. So now let's look at what are the formulas that determine these two. Here's your formula for permutations. It is designated as PNR, whereas N, and there's other ways to do it, but this is the most common form. What is N? N is the number of people in the number of possibility, the number in the set. The total number in the set. The R is the number in the group you're choosing, the subset, okay? So, that's the difference in those numbers. So, your permutation formula is this: n factorial over n minus r factorial. In other words, you subtract the r from the n before you do your factorial. Your combinations, on the other hand, nr, its equation is n factorial over r factorial times n minus r factorial, which makes your denominator larger, and thus your total number of choices will be fewer and smaller. Okay, so that's basically what permutations and combinations are. There's other elements in these that are important. For combinations, permutations, let's look at elements that these are characterized by, characteristics of these two actions. Okay, choosing a specific number of objects from a larger group. Okay, that's one thing. In combinations, the object chosen cannot be replaced into the large group. So once it's chosen, it's chosen. Order is not important. That's what we stressed earlier. And we listed that ABC, CAB, BAC are all one group. They're the same group. That's what it means when it says order is not important. Okay, let's look at permutations. Okay? Number one is the same in permutations. You're choosing a specific number into a smaller group from a larger group. That's exactly the same. The object cannot be put back into the larger group after it is chosen. You can use it only once. That is exactly the same. But the difference is right here in the order. The order is important. And what that means is this: ABC, BAC, CAB are three different groupings. So these are the characteristics of permutations and combinations. We will do one more lecture on this, but we're going to stop this one because I have to go teach. Talk to you later.